In this video, I'm going to go over how you multiply two complex numbers. So let's get right into it. So for this example, we've got z1 and z2, and we're going to want to multiply them. So first, if you have them in rectangular form, or a plus bi, it's just as simple as expanding out two brackets. Let's say z1 is equal to 3 plus 4i, and z2 is equal to 7 plus 6i. So these aren't the actual numbers of the z1 and z2 that I've put up on screen, but they're just an example for this one. So to find z1 times z2, we're just going to do 3 plus 4i times 7 plus 6i. So then from there we can just expand out using normal methods. So that, and then that, and then that, and then that. We're going to need to remember that I squared equals -1. That will come into, that'll be handy later. So 3 times 7 is 21, plus 3 times 6 is 18. So 18i, because we have that I term there. Now 4 times 7 is 28, so plus 28i. And then 4 times 6 is 24, so plus 24 I squared. So simplify, 21 plus 18 plus 28 is going to be 46. And then I squared is -1, so this is going to be plus 24 times -1. And we're going to get 21 plus 46i minus 24. So we're going to get -3 plus 46i. Cartesian form like that. Now, the other two ones, which are polar and exponential, are very similar in the way that you do it. So for polar, we are going to multiply the radius, or the argument. We're going to go argument of z1 times the argument of z2, and we're going to have that outside of cos of theta 1 plus theta 2 plus I times the sine of theta 1 plus theta 2. So now let's do a practice problem like that. So let's use the same ones. z1 is equal to 3 plus 4i, and z2 is equal to 7 plus 6i. So the argument of z1 is going to be the square root of the sum of the squares of the individual terms. So that sounds like a lot, but that's just going to be 3 squared plus 4 squared. We can put that into our calculator and find out that that would be the square root of 25. And now the modulus is always positive. So this here will just be the positive side of this. We're not going to get a -5. We're just going to get a regular 5. Let's turn off math results. Modulus of z2 is going to equal the square root of 7 squared plus 6 squared. It's going to equal the square root of 49 plus 36 is equal to the square root of 85. Now, to find the angle theta here, the angle theta will be the tan inverse of the imaginary part over the real part. I don't know why I'm putting z1. It's just like that. So, the argument of z1, tan inverse of the imaginary part is going to be 4, the real part is going to be 3, so 4 over 3 is going to equal, so we can just put that into our calculator, and that's going to equal 0.92. Always work in radians. Let's find the argument of z2. we're going to take the imaginary part, or 6, over 7. It's equal to, let's put that into our calculator, it's going to equal 0.71, because we'll round to 2 decimal places. Now, we have just found that Z1, if we're writing it in polar form, is going to equal the argument, or 5, that we found from there, outside of the cos of 0.92, plus I times the sine of 0.92. And a shorthand way of writing this is 5 cis 0.92. Cis being cos, I being I, and S being sine. So now Z2 is going to equal, we're going to take the modulus, or the absolute value that we found here. So we're going to have root 85 outside of the cos of 0.71 plus I times the sine of 0.71. Or Z2 is equal to square root of 85 cis 0.71. Now, finding Z1, Z2 is as simple as timesing 5 by the square root of 85. So 5 times the square root of 85 outside of cis, because we can just shorten it down, of 0.92 plus 0.71 is equal to 5 times the square root of 85 cis 1.63. There we go, there is our answer. Exponential form. Let's do a bit of work on that. So let's not find the argument and everything. Let's just say Z1 is equal to 7e to the I pi on 4. So that means our theta is going to equal pi on 4, and our radius, or our modulus, is going to equal 7. Now Z2 is going to equal 4e to the I pi on 3. Whoa. E to the I pi on 3. So Z1, Z2 is equal to 7 times 4, e to the I pi on 4 plus pi on 3, or 28. So we can simplify that. E to the I is going to be 7 pi on 12. There we go. And that is how you multiply complex numbers, whether they are in Cartesian form, polar form, or exponential form. Hope this helped a little bit, and hopefully I see you again in another video.